Relying solely on text prompts often makes it difficult for the model to strictly meet requirements such as specific composition, depth of field, character poses, and so on. In such cases, we need to introduce ControlNet. This adds an additional parallel control branch that injects structural signals like skeleton, edges, and depth information from a reference image layer by layer into the U-net during sampling. The model thus conforms not only to the semantic meaning of the text prompt, but also to these structural constraints. So, how does it perform in practice? Let's test it out. Start by creating a new blank workflow. Add an all-in-one preprocessing node and connect the finished image from our previous text-to-image process. Add a preview node for easy output viewing. There are many types to choose from in this node. Let's start with depth anything 2, which reflects the depth relationships, foreground and background of objects. Set the resolution to 1024 for more detailed results. Click Run. The resulting grayscale image is the depth map. Closer areas are brighter, distant ones are darker. In the same way, switch to Edge and Pose preprocessors to obtain a line art image and a skeletal pose image, respectively. Now back to the original text-to-image workflow. This time, we want the newly generated character to preserve the reference pose. Remove the low-raw loading node and revert to the basic model pod prompt setup. Load the reference image and use the preprocessor to extract its pose. Then, using the Apply ControlNet node, append this pose signal to both the positive and negative prompt conditions. It's recommended to start with a low strength value and adjust based on the results. Here, I set it to 0.8. Set the start time to 0, end time to 0.8. Like the preprocessor, ControlNet also offers multiple types. Here, use a compound model, Union Pro. Note, after downloading the model file, place it in the model's ControlNet directory. Set the control type to pose. Complete the remaining connections. Input the preprocessed pose image and corresponding VAE. Pass the positive and negative prompts, now appended with control signals, to the sampling node. Edit the subject in positive prompt to an anime-style girl. Click Run. The generated image appears, a pink-themed girl. The overall style is completely different from the previous reference image, which was more mature in style, but look closely. The character's pose is exactly the same in both images. Within Flux Tools, there are also line art and depth ControlNet models in low-raw format. These are even easier to use, but do not allow setting the action time. We will not cover them here. ControlNet excels at structural constraints such as pose, depth, edges. But if we only want to borrow the overall style, color scheme, or atmosphere of a picture without strictly copying its details, we need more generalized style conditioning. For this, we can use IP adapter, or, in the Flux ecosystem, the more suitable Redux. First, remove the earlier ControlNet-related nodes and return to the basic workflow. Add an Apply Style Model node. This works similarly to ControlNet. It appends additional condition encodings to the prompt and feeds them into the sampling process. This node requires two inputs. One is the Redux model loader, which reads model files from the model style models directory. The other is a SigCLIP Vision model, which encodes the reference image into vector format. Redux requires the use of the SigCLIP Vision patch 14.3a4 Vision model. After downloading, place it in the model's CLIP Vision directory. Continue using the same reference image as before. To examine Redux's pure style transfer capability, temporarily clear the text prompt and simply click Run to see what results Redux produces alone. Once generation is complete, you'll get a new image very similar to the original. Same color palette, lighting atmosphere, and material feel. Even though the textures and details do not exactly match, you'll definitely feel they belong to the same series. This is the function of style conditioning, softening rigid structural constraints and emphasizing overall aesthetic qualities. If you want precise control over activation timing and strength, similar to ControlNet, when using Redux, try the Advanced Reflex Control plugin. The workflow is straightforward, so we won't demonstrate it here. The vast majority of models follow this text-to-image workflow. The sampler takes just two inputs, the model and prompts. Various conditions such as prompts, low-raw, reference image information, etc., are passed through these two inputs. The model performs iterative latent-space sampling conditioned on them, and the VAE decoder produces the final pixel image. However, a small number of models skip the latent space and paint directly in pixel space. For example, the Chroma 1 model, the official ComfyUI template library, includes its workflow. you'll see VAE load and decode nodes in the process, but in reality, they are just placeholders. The VAE model is named pixel space, and decoding is a simple pass-through. Let me run it for you. The image generates without issue, and decoding is extremely fast. Visually, there's no obvious difference between these two methods, but non-latent space models bypass VAE limitations. Color, contrast, and dynamic range are more accurate, and the theoretical upper limit on quality is higher.